When enough bubbles pop, the water and remaining gas becomes more dense than the oil. So the ball of water sinks down through the oil and joins the rest of the water. Changes in density as gas is added to or taken away from water cause it to float up and sink down through the oil. Thus, the lava lamp is created. There's a lot of carbon dioxide dissolves in the soda, which give it its fizz. When you drop a Mentos into a soda, tiny bumps of the candy surface give the carbon dioxide molecules an accretion site or place to stick. As more and more carbon dioxide molecules accumulate, bubbles form. Paper towels are highly porous. These pores function like tiny tubes or capillaries to draw up water. Two properties allow to this happen. The first is adhesion. Water molecules are attracted to the walls of the capillaries and stick to them. This is enhanced in our experiment because paper towels are made of cellulose molecules that are highly attractive to water. The second property is cohesion. The water molecules like to stick to each other. Together, these two properties allow the water to travel along the paper towel against gravity, moving out of one container and dropping into the other. When the leaf is submerged, it is using light to continue the process of photosynthesis. Part of this process is to let oxygen out of the leaves. It is this oxygen that you are seeing as bubbles in the water. So while a plant does not breathe like we do using lungs, it does take in and release air. The water cycle is responsible for producing rain. Liquid water evaporates, sending water vapor into the atmosphere. When the water vapor reaches the colder air in the upper atmosphere, it condenses back into water droplets, forming clouds. If too much water condenses or if the temperature becomes colder, the condensed water will fall back down to earth in the form of rain. In this experiment, we replicated this condition to produce rain. First, we let the heated water form water vapor inside the jar. The water vapor filled the space between the water surface and the plate. We then added ice to our plate, initiating a quick temperature drop. The lower temperature caused the water vapor to condense. This was visible as water droplets that beaded and ran down the sides of the jar. This is how rains happen. We made it rain inside our jar. Have you ever tried to mix oil and water? The fat molecules in oil, just like the ones in milk, are hydrophobic, meaning they don't like to be near charged molecules such as water, and will do whatever they can to keep away from them. To achieve this, they clump together. Because the fat molecules are less dense than water, the fat globules float up and form a layer above the water. In our experiment, we added food coloring to this layer of fat globules. Dish soap is a detergent. Detergent molecules have a hydrophobic end and hydrophilic end. Because of this, they are able to form a bridge between the fat molecules and the water molecules, causing the fat globules to break up and disappear. What we're seeing when we add the dish soap in this dispersal of the fat clusters, pairing the food coloring with it and resulting in a beautiful tie-dye pattern.